Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazugai is going to deal with Applied Thermodynamics 2. This is our 15th lecture. In previous lecture we have discussed about Dalton's law of partial pressure and psychometric relations along with the psychometric chart. So now today we are going to discuss a numerical on psychometric properties as well as use of psychometric chart. Let us consider first one numerical. So the reading from a ceiling psychometer are as follows. Ceiling psychometer in the sense the thermometer with wet bulb as well as open bulb which indicates dry bulb temperature and wet bulb temperature. So dry bulb temperature for this thermometer which is given as 30 degrees Celsius and wet bulb temperature is given as 20 degrees Celsius. So now in this the barometric reading in the sense it is the atmospheric pressure which is given as 740 mm of Hg. 740 mm of Hg is the atmospheric pressure, that is nothing but pressure indicated by barometer. Then he is asking us to find out following parameters such as dew point temperature, dpt. Then it is asking us to find out relative humidity, then specific humidity, then degree of saturation mu, vapor density, and enthalpy H. So these things have to be obtained. So before starting to solve this problem, let us have the plan to solve this problem. So what is given in this problem is dry bulb temperature of air is given, then wet bulb temperature is given. So dry bulb temperature is 30 degrees Celsius, wet bulb temperature is 20 degrees Celsius, whereas the barometric pressure, that is atmospheric pressure, is 740 mm of Hg. Then it is asked to find out dew point temperature, relative humidity, that is phi, then specific humidity omega, degree of saturation mu, and vapor density rho v, and enthalpy H. So to solve this we'll have the plan. So what we want to find out is first dew point temperature. We want to find out dew point temperature. So to find out dew point temperature, the dew point temperature is the saturation temperature corresponding to the partial pressure of water vapor. So it is the dew point temperature is the temperature corresponding to partial pressure of vapor. Therefore we can find out this partial pressure of vapor from steam table. So first our aim is to find out dpt, that is dew point temperature. So to find out dew point temperature, we must know partial pressure of vapor, that is PV is required. So if we know PV, then we can find out dew point temperature. So to know this partial pressure, so equation for partial pressure, that is PV is equal to PW, partial pressure of water, minus of PB minus of PW into TD, dry bulb temperature, minus of TW, wet bulb temperature, divided by 1544 minus 1.44 TW. So in this what we know is barometric pressure is known, and then we can find out barometric pressure in terms of bar. So here PB is given. So to find out PB, which is given in 740 mm of Hg, so rho gh, that is rho of mercury, acceleration due to gravity, h which is given is 740 mm of Hg. This is to be converted into meters. So here PB has to be converted into bar, so therefore we have to divide it by 10 to the power of 5. So rho gh gives us a barometric pressure in Newton per meter square. If we substitute h in meter, rho density in kg per cubic meter, and g, acceleration due to gravity, 9.81 meter per second square. So then we get by dividing this by 10 to the power of 5, so this gets converted into bar. So PB is known, PW is not known here. Temperature, dry bulb temperature is known, wet bulb temperature is also known. Wet bulb temperature is known, only PW is not known. PB we know, but it is in terms of mm of Hg, so this is to be converted into bar. Then to find out PW, so it has to be taken from steam table at the pressure of, sorry, at temperature of dew point, wet bulb temperature. So at 20 degrees Celsius from steam table, the corresponding pressure is known as a saturation pressure, and that saturation pressure corresponding to wet bulb temperature of 20 degrees Celsius, that is known as PW. So this has to be taken from steam table in bar. So everything is known. PV we get. Once we know PV, corresponding to PV we can find out dew point temperature. So this dew point temperature is over here. So this is the plan. So we must start in reverse way. So first we find out PW, then we find out PB, then we find out PV, and from PV we can find out dew point temperature. Now second term that we want to find out is relative humidity. So relative humidity RH, or in short this is given as phi also. This is given by PV by PS. So we know PV already, we have obtained in previous case. Here PV is known, so only unknown is PS. So to know PS, what we have to do is we know dry bulb temperature. So corresponding to dry bulb temperature at 30 degrees Celsius dBT, dry bulb temperature, we must know pressure, and that pressure PS, saturation pressure, we can know from steam table. So this is from steam table. So by knowing this saturation pressure in bar, PV is known in bar, so we can find out relative humidity RH. Then third thing that we have to find out is specific humidity. So to find out specific humidity omega, so formula is 0.622 PV divided by PB minus PV. So we know PV, we know PB, everything is known, so omega can be obtained. Then fourth is, already we have obtained PB here and PV also here. So PV we substitute, then we can find out relative humidity. Then to find out degree of saturation, that is mu. Mu is obtained by the ratio of omega divided by omega s. So what is omega? Omega is nothing but the specific humidity, and omega s is a specific humidity of saturated air. So omega already we have calculated. Then to find out omega s, so what to do is omega s is equal to 0.622 PS divided by PB minus PS. So PS is known to us already, we have obtained PS somewhere here. So this value of PS which we have obtained here from steam table, so that is to be substituted, and from that we get WS, and from WS we get mu, that is degree of saturation. So this is to know degree of saturation. Then next comes vapor density rho V. Vapor density is given by omega in bracket PB minus of PV divided by RA into TD, dry bulb temperature, that is absolute dry bulb temperature in degree Kelvin. So this is important here. So what we must remember is this drivable temperature must be in degree Kelvin. So omega is known, PB is known, PV is known, and R is also known. So we can find out TD is also known, or rho V we can find out. So lastly, he is asking us to find out enthalpy of air. So enthalpy of air is obtained by formula H. H is equal to, so that formula is 1.022 TD plus of omega HFG, latent heat of vaporization at dew point temperature, plus of 2.3 TdP, dew point temperature. So this gives us enthalpy. So omega is known. HFG at dew point temperature can be taken from steam table. Dew point temperature is also known, which is already calculated in first step itself. So dew point temperature is known. So everything is known. Drivable temperature is known. H can be obtained. So let us start to solve this problem slowly. So how to start this problem is very important. So first of all, we can find out PW at 20 degrees Celsius wet bulb temperature, then PB converted into bar, then PV, then dew point temperature. So always we start from bottom to top for every term. So when we want to find out dew point temperature, start from PW. Then when we want to find out RH, then start from PS. So this is how we will attempt this problem. So now very first, to solve this problem, first of all we must know this PW. So from steam table, so you can refer steam table. From steam table, saturation pressure corresponding to wet bulb temperature WBT, which is WBT is 20 degrees Celsius. That is known as PW, which is equal to 0.02337 bar. So this gives us PW. Then to find out PB, barometric pressure, which is given. So PB which is given is 740 mm of Hg. So to know this PB in bar, PB is equal to rho GH divided by 10 to the power of 5. So if we substitute this rho GH, then we get it in Newton per meter square. When we divide it by 10 to the power of 5, then it becomes in bar. So rho 13,600 is the density of mercury into 9.81 meter per second square is acceleration due to gravity, and H is 0.740. So this is important. This is to be substituted in meters and divided by 10 to the power of 5. Then we get this as 0.98642 bar. Then we get it as 0.98642 bar. So this is PB. Now we know PB also. PB is known to us, that is 0.98642 bar. Now we know PW, we know PB. So once we know PW, PB, we can find out partial pressure of vapor. Partial pressure of partial pressure of water vapor is given by PV is equal to PW minus of PB minus PW into TD minus TW divided by 1544 minus 1.44 TW. So PW we know that is 0.23, sorry, 0.0 0.02337 minus PB is 0.98642 minus PW is 0.02337 into TD. Dry bulb temperature is 30, wet bulb temperature is 20, divided by 1544 minus 1.44 into TW. So TW value is known to us. TW which is given to us is 20 into 20. So on simplification we get this as 0.01701 bar. So this is partial pressure of water vapor. Now corresponding to this partial pressure of water vapor from steam table, corresponding to PV is equal to 0.01701 bar. The temperature T is equal to 15 degrees Celsius, and this temperature is known as dew point temperature. So this is TDP, which is equal to 15 degrees Celsius. So this is how we obtained the dew point temperature corresponding to partial pressure of vapor. Now coming to next term, that is relative humidity. Relative humidity, in short, RH, or sometimes it is referred as phi. So formula for this phi is given as phi is equal to PV divided by PS. Already PV we know, PS is not known. So to find out PS, so corresponding to dry bulb temperature dBT, which is 30 degrees Celsius from steam table, the pressure which is given is pressure P is equal to 0.04242 bar. So this pressure is nothing but the saturation pressure PS corresponding to this dry bulb temperature. So when steam becomes saturated, at that time the pressure of saturated steam, when this air becomes completely saturated with water vapor, so partial pressure of steam in a air is 0.04242 bar. So therefore phi can be obtained now. Phi is equal to PV divided by PS. So PV just now we have obtained, which is 0.01701. So this we have obtained here, 0.01701. 0.01701 divided by PS is 0.04242. So this is phi is equal to, we get 0.4, or this can be written as relative humidity is 40%. Then the next term is specific humidity. Specific humidity omega. So this specific humidity omega is given by formula 0.622 PV divided by PB minus PV. So here we know PV, we know PB, everything is known. So only the values we need to substitute, 0.622 into PV, which we have calculated in previous case, is 0.01701 divided by PB, which we have calculated as 0.98642, minus PV is again 0.01701. This we have calculated, and from this we get this as 0.010914 kg per kg of dry air. So if this is to be calculated in gram, then it will be 10.914 gram per kg of dry air. So this is omega, so which is known as a specific humidity. Then coming to the next term, degree of saturation. Degree of saturation, which is given by mu, and this mu is equal to omega divided by omega s. So we know specific humidity omega. So this omega s is specific humidity of saturated air. So omega is known, omega s is this specific humidity of saturated air, which is given as 0.622 PS divided by PB minus PS. So already PS is calculated, which is known to us in previous case itself. So here we have obtained PS value as 0.04242. So this value of PS we will be using now. So here 0.622 into 0.04242 is PS value, and PB is 0.98642 minus of 0.04242. So we get omega s, that is 0.027945 kg per kg of dry air. So then mu can be obtained. Mu is equal to omega divided by omega s. So omega, which is known to us, is 0.010914 whole divided by 0.027945. So this degree of saturation is 0.391 or this is 39.1%. Then this mu can also be obtained by another formula. Mu is equal to PV divided by PS in bracket PB minus PS divided by PB minus PV. So if we substitute these terms, again we get mu value, that is degree of saturation. Then coming to the next term, that is vapor density. Rho V, which is given by omega into PB minus PV divided by RA into TD. So we know everything in this equation. Omega value is known, that is 0.010914 into PB value is known, that is 0.98614 minus PV value is known, that is 0.01701 whole divided by R value, that is 287 joules. 287 into TD is dryable temperature is 30 degrees Celsius, 273 plus 30. So this must be in degree Kelvin. So this is important parameter to remember. This TD must be in degree Kelvin, and this must be in kilojoules, joules per kg Kelvin. So this must be in joules per kg Kelvin, this must be in degree Kelvin. So after calculation we get this as 0.01216 kg per meter cube of dry air. So this is a vapor density. So next term which we want to find out is enthalpy of mixture. Per kg of dry air. Which is given by H is equal to 1.022 T suffix D plus of omega into HFG at dew point temperature TDP at dew point temperature plus of 2.3 into dew point temperature TDP. So now we know this 1.022 into dryable temperature is 30 degrees Celsius plus of 0.010914 into H value at dew point temperature corresponding to the dew point temperature, which is 15 degrees Celsius, which we have calculated. So dew point temperature which we have calculated here is 15 degrees Celsius. So corresponding to 15 degrees Celsius temperature, latent heat of vaporization at dew point temperature of 15 degrees Celsius, HFG is equal to, from steam table if we see, this is going to be 2466.1 kilojoules per kg. So this we substitute here 2466.1 plus of 2.3 into dew point temperature is 15 degrees Celsius. So on simplification, this enthalpy works out to be 57.95 kilojoules per kg. So this is how we have simplified this, and we'll have the summary of this question. Very first, what we have obtained is dew point temperature. So first parameter is dpt, which was asked is 15 degrees Celsius. And second thing which was asked here is relative humidity phi, which is 40%. Third thing which was asked to us is specific humidity omega, which is 10.914 gram per kg of dry air. Then fourth, degree of saturation mu, which we have obtained as 39.1%. And fifth, we obtained vapor density or rho v as 0.012 kg per meter cube of dry air. And sixth thing which we have obtained is enthalpy H is equal to 57.95 kilojoules per kg. So now next that we want to find out is we'll have this data we'll compare this data with the psychometric chart. So now we'll discuss the things with the psychometric chart. What is given in this problem? Very first thing which are the things which are given to us is dry bulb temperature and wet bulb temperature are given. So dry bulb temperature is 30, wet bulb temperature is 20 degrees Celsius. So corresponding to these two things, we'll find some information from this psychometric chart. So dry bulb temperature is 30 degrees Celsius. So this on x-axis, this is 30 degrees Celsius, corresponding to 30 degrees Celsius, and wet bulb temperature is given as 20 degrees Celsius. So this is the point where point A, where wet bulb temperature line of 20 degrees Celsius and dry bulb temperature line of 30 degrees Celsius intersect at point A. So from corresponding to this point A, we want to find out all other parameters. So in first instance, dew point temperature is asked. So dew point temperature is a horizontal line corresponding to this. If we go here, corresponding to this, so it comes here. So horizontal line indicates dew point temperature. So I will draw a horizontal line passing through this. So this horizontal line represents dew point temperature. We can have another line extension of this line. Okay, so corresponding to this point A, if we extend this point in horizontal direction, here is 15 degrees Celsius. This 15 degrees Celsius is dew point temperature. So dew point temperature is identified. dpt is 15 degrees Celsius from this graph. Then second thing which is asked to us is relative humidity Rh. So if we see here the line curve passing through this relative humidity, this is 30 degrees Celsius, 40 degree 40%, 30%, 40% and 50%. This is the 30%, this is line of 40%, and this is the curve of 50%. So this curve is passing, therefore relative humidity phi is 40%. The next thing which is asked is omega, specific humidity. So if we see specific humidity, sorry, just a minute, 40% specific humidity, if we see corresponding to this point A. So here is the specific humidity. It is greater than 0.01. Omega is 0.01017, which was greater than this, so it is higher. So something extra if we write this is omega. Then third thing which is asked is mu. So mu, these lines I think are not shown in this chart graph. So okay, we will search for that graph and then we will discuss about those degree of saturation. Then next thing which is asked is vapor density. So now constant specific volume is given. Specific volume is given. So corresponding to this, specific volume is between 0.78828486, between 86 and 88. So if we consider it as 0.85, so specific volume is 0.85 meter cube per kg. So reciprocal of this, if we take, you get the density. So somewhere it is around 0.85, reciprocal of 0.85 specific volume. 1.17. Specific volume is given. Then specific enthalpy, if we extend this point to this somewhere here, so this is 50, 55, 60. So if we extend this, it will be enthalpy is H is equal to 55 kilojoules per kg. So most of the things we have seen here. So this was 57, we obtained this as 55. So these two things we cannot obtain from here because the curves are not shown. So this is also obtained, this is also obtained, this is also obtained from a graph. So this is how we can use graph for finding properties of air from moist air. Properties of moist air can be obtained just by knowing dryable temperature and Verdal temperature. All the properties can be obtained. So now coming to the next problem, we'll see one more problem where now for the sample of air having 22 degrees Celsius dryable temperature and relative humidity is 30% and barometric pressure is 760 mm of Hg. So he is asking us to find out vapor pressure, humidity ratio, vapor density, then enthalpy of mixture per kg of dry air, and then verify results with psychometric chart. So now coming to this data given, dryable temperature is given as 22 degrees Celsius, relative humidity is given as 30% and barometric pressure is given as 760 mm of Hg. So he is asking us to find out vapor pressure, humidity ratio, vapor density, enthalpy of air, and this data we have to verify with what you say psychometric chart. So now very first is vapor pressure. We want to find out PV. So to find out vapor pressure, we know this formula for relative humidity phi. Phi is equal to PV divided by PS. So now we know PS, we can find out PS, and we want to find out vapor pressure. Phi is known, we want to find out PV, and PS can be obtained. So PS can be obtained at dBT is equal to 22 degrees Celsius from steam table. So it is very simple. Phi is known, PV we want to find out. PS can be obtained from steam table at 22 degrees Celsius dryable temperature. So this is one thing that we can obtain by knowing simply PS from steam table. Substitute PS, humidity, relative humidity is given. So relative humidity we substitute here as 30%, that is 0.3, and we get PV. Then next thing is he is asking us to find out humidity ratio. So humidity ratio omega is equal to 0.622 PV divided by PB minus PV. So PV is known in first case, then PB can be obtained, so 760 mm of Hg. So PB is equal to rho GH divided by 10 to the power of 5. So this gives us PB in bar. So this PB we substitute in this equation, we get humidity ratio. Then third one is vapor density. So to know vapor density rho V, we must use this formula omega PB minus PV divided by RA into TD. So we can find out rho V. So we know omega, then PB is known, PV is known, RA is known, TD is known. So we can find out rho V, that is vapor density. The next one is enthalpy. H is equal to 1.022 TD plus of omega HFG, latent heat of vaporization at dew point temperature, plus of 2.3 dew point temperature. So here dew point temperature we must find out. So dew point temperature is taken at PV is equal to, so dew point temperature, from dew point temperature we can find out PV, or if we know PV we can find out dew point temperature from steam table. So reverse. So everything we can know. So dew point temperature we can obtain from PV because PV is known in first case itself. So PV is obtained here. So from PV we can find out DP. From DP we can find out HFG, and from this HFG and everything we can find out H value. And then these are to be compared with the standard results, that is the psychometric chart. So very first is vapor pressure. So vapor pressure is given by to find out vapor pressure, phi is equal to PV divided by PS. So to know PS at dry bulb temperature dBT, which is equal to 22 degrees Celsius, 22 degrees Celsius from steam table, PS is equal to, we get this PS as 0.02642 bar. So PS we can substitute phi, we know that is phi is equal to 30% means 0.3, which is equal to PV divided by PS is 0.02642. So PV is equal to, we get this as 0.007926 bar. So this we get PV, in this case vapor pressure. Then second term we want to find out humidity ratio. Omega is equal to 0.622 into PV divided by PB minus of PV. So we know everything, only PV is not known. PV is equal to 760 mm of Hg, which is given mm of Hg. So this has to be converted into bar. So PB in bar can be converted as rho GH divided by 10 to the power of 5. So rho is 13,600, density of mercury is 13,600 kg per meter cube into 9.81 meter per second square is acceleration due to gravity into H is 760 means 0.760 meters divided by 10 to the power of 5. So this barometric pressure PB works out to be 1.01308 bar. PB is known. So now 0.622 into PV. PV is 0.007926 divided by PB is 1.01308 minus PV. PV is 0.007926. So on simplification it works out to be 0.0049 kg per kg of dry air, or this can be written as 4.9 gram per kg of dry air. This is humidity. Then humidity ratio. Then coming to this next, vapor density. Rho V which is equal to omega PB minus PV whole divided by RA into TD. So omega we know, that is 0.0049 kg per kg of dry air into PB is 1.01308 minus PV is 0.007926 divided by RA is 287 into drivable temperature is 273 plus of 22 degrees Celsius. So on simplification this works out as 0.00582 kg per meter cube of dry air. So then last thing that we want to find out is enthalpy. So enthalpy H is given as 1.022 TD. TD means drivable temperature plus of omega into HFG at dew point temperature TDP plus of 2.3 into dew point temperature TDP. So we know PV. So PV which we obtained is here is 0.007926 vapor pressure is in bar. So corresponding to this vapor pressure, temperature is known as dew point temperature. From steam table we can find out dew point temperature corresponding to this vapor pressure, which is 3.8 degrees Celsius. TDP is known. So corresponding to this TDP, we can find out enthalpy of vaporization, that is HFG, and that works out to be 2492.6 kilojoules per kg. So first we know PV. From PV we obtain DP. and from this PV and DP we obtain latent heat of vaporization from steam table, that is HFG. So this HFG can be used here. So now H is equal to 1.022 into dryable temperature is 22 plus omega, that is 0.0049, in bracket HFG is 2492.6 plus of 2.3 into dew point temperature, which we obtained is 3.8 degrees Celsius. So on simplification we get enthalpy as 34.74 kilojoules per kg of dry air. So this is how we get enthalpy. So now we'll summarize this data which we have obtained here is, first we obtained vapor pressure PV, which was 0.007926 bar, and second we obtained humidity ratio, that is omega, which is equal to 0.0049 kg per kg of dry air. Then vapor density rho v is equal to 0.00582 kg per meter cube of dry air. Then we obtained enthalpy H, which is equal to 34.74 kilojoules per kg of dry air. So this is how we obtain this information. Now coming to this psychometric chart, two things which are given in this problem are dryable temperature and relative humidity. Dryable temperature is 22 degrees Celsius, relative humidity is 30%. So on this graph, the relative humidity is 30% and dryable temperature is 22. So 22. From this it is here. Point A is marked here. From 22 vertical line and 30 degree Celsius. So point A is marked. So corresponding to this 30 degree Celsius, we have to find out this vapor pressure PV. So vapor pressure lines. Okay. Now corresponding to this, if we see, dew point temperature is 5 degrees Celsius. Then corresponding to this, if we go in this direction, somewhere here we come. So here 0.002, 0.004, 0.00459 something, 0.004. So here 0.002. So this is kg per kg of dry air. So this is omega. Then what we have obtained here is enthalpy H. So corresponding to this, if we take a straight line here, somewhere it comes here 30. So how much was enthalpy? 34. So it is approximately more than 30, between 30 and 35, or something somewhere here it is 32, say, kilojoules per kg. So enthalpy is also obtained. Then PV So this graph does not contain other curves also. If it contains other curves, we can find out some other parameters which we are supposed to find out. So one more specific volume. So there must be a curve passing through this specific volume curve, like this curve must be there. So that curve is not shown here. So we can take here specific volume corresponding to this. So whether we have obtained specific volume? No. Specific volume is not calculated. No problem. So here specific volume can be obtained at this, corresponding to this, it is 0.84. So specific volume is 0.84 meter cube per kg. So corresponding to this point. So this curve is straight line, is specific volume line. So this is how we can get the information using psychometric chart. So from here you find dew point temperature, you find enthalpy, then you find specific humidity, then humidity ratio, interval temperature is here. So the things can be obtained from psychometric chart also. So here we stop, and in next class we will be looking at psychometric processes. Thank you.